All right, guys. So for today, what we're going to do is we're going to talk about going into exponential functions, exponential models. So the central question today is, what is an exponential function and how is it different from a linear function? Okay, so we're going to talk about that today. We're going to introduce exponential functions, the graphs, how to put your input, output, how to do all those type of things. Okay. Okay, guys, you just want to follow along with your notes. So the first definition of an exponential function, exponential functions, all right, is a function of the form y is equal to a times b to the x, okay, where a is not equal to 0, okay, so this means not equal, and b is greater than 0, so that means b it can't be 0, it must be any number greater than 0, so you got 1, 2, 3, any number greater than 0, and b cannot be equal to 1, okay, again, a cannot be equal to 0, so this right here cannot be equal to 0, and b must be greater than 0, but cannot be equal to 1, okay? And the exponent must be a variable, okay? So this part, the exponent right here that we're looking at, this must be a variable, okay? Must be a variable when you start off with your function. Some things to remember, guys, when we're going through exponential functions is we have y times b to the x, and I already had this on your paper. Y is known as always as your output, okay, or your y value, okay. A, in this case, will be known as your initial amount, okay. Initial amount, trying to write it with my finger, but that's initial amount. It's already on your paper, all right. And then we know B is your rate. So is it doubling? Is it tripling? What is that rate? What is that rate talking about? We know X is talking about, that's going to be your input, okay? So that's going to be your X value, your input, which you input into the equation, all right? All right, let's keep moving. All right, so now let's take a look at an exponential function, okay? The exponential function we're going to have for today is a very simple one, the one we start off with all the time. Y is equal to 2 to the x, okay? So y is equal to 2 to the x. Now, on your paper, you have a t-chart and you have the graph already drawn, okay? What you guys are going to do is pause your video now and you go through and find your y's, okay? How do we find our y's? What you want to do is you want to take y equal to x, and we just said x is going to be our input. So on your t-chart, you have -2, -1, 0, 1, and 2. Okay, so let's input one of the positive. I'm sorry, we're going to input one of the positive numbers in first, so you can see how it looks. So y is equal to 2 to the second power. Now, we already know, guys, from what we've been dealing with, 2 to the second power is what? 4. So y is equal to 4. Okay, so that's my output now. So I inputted 2, which is my x, and I outputted 4, which is my y. Okay. Skip to another. Let's do a negative one now, because we know 0 and we know 1. Those are pretty easy. So let's try a negative. Let's got y is equal to 2 to the x. And let's try -1. Let's put no. In fact, let's do -2. Let's do -2. So y is equal to 2. Input -2 for my x. So we know dealing with negative exponents. Okay. If I have a negative exponent right here, I want to do the reciprocal. So I want to flip this. So we're going to do y is equal to 1 over 2 to the second power, because now my 2 becomes positive after that. And you know 2 squared again is 4. So y is equal to 1 over 4. Okay, so this is how we did it with 2, and this is how we did it with -2. Okay, now you're going to see, I'm going to go ahead and hit the chart, and you'll be able to see the rest of your y-intercepts, or you can try them on your own. It's completely up to you. So here we go. We had 1 to the 1/4, 1/2, 1, 2, and 4. And this is how your graph should look. You already have that graph on your paper, guys. All right, so that's the exponential function. You can replay this as many times as you need to, but that's the exponential function. Now we're going to see how changing our a and b, okay, can make our graph also change. So we'll make it increase faster, it'll widen the graph out, it'll make it flatten out, it'll make it, like I said, increase faster, increase slower. So that's what we're going to see right now, okay? So y is equal to a times b to the x. Okay. Our general form is simple enough. The general shape of our graph will be determined by the exponential variable. Make sure you guys put this in your notes, okay? That's what's missing right there. All right. So we have, so which leads us to ask what the role of A and the base B plays here. Let's take a look. Okay, so we have two graphs we're going to look at. All right, let's change the B values first. So let's change our rate first and see what happens. So let's look at this for example. Okay, we have y is equal to the x. We just did a problem like that. Now let's point out a couple things about this one. So we see it hits the graph, the y-axis, okay, right here. Let's say that's 1. I'm trying to make that point here. So it hits it there, okay. Again, this one, y equals 5 to the x. The rate changed to 5, so now it's growing. Let's see what happens to those graphs right here. You also have these graphs on your paper that I created for you guys. All right, it's still hitting this y-intercept at 1. The y-intercept here is still at 1. Okay, what conclusion can we draw from this? Let's look at this. Let's look at this. We have y equals 2 to the x, y equals 5 to the x, and we have y equals 15 to the x. Now, for me, just looking at this graph, looks like the line is getting closer to the y-axis, right? Like it's increasing faster as the rate grows. Okay, the rate grows, the increases faster. So let's look at an example of this. Let's look at y is equal to 1, okay? So when x is equal to 1. So let's plug it in for all of them so you guys see what we're talking about. X is equal to 1, okay? So y equals 2x. We know we plug in 1 right there. That'll be y equals 2, right? So y is equal to 2 here. At x equal to 1, y is equal to 5. At x equal to 1, y is equal to what? 15. So you could just see that after it passes the y-intercept, it immediately shoots up, okay, to 2, 5, or 15 when you change that rate, okay? And you can get a little bit more practice with this as we go on further today. But let's keep moving. Okay, now guys, just go ahead and flip to the back. It's the last part of talking about exponential functions, then you're going to get to your practice. All right? So, again, y equals a times b to the x, okay? Now let's see what impact A has on our graph when we fix the value of B at 3. So our rate is 3, but our A's are going to change. All right, we're going to look at all positive values of it today. Okay, so let's keep looking. So all have different values. Okay, let's see what's happening. All right, are they increasing faster? A little bit in some of them. But let's look at these y-intercepts. Okay, let's look at these y-intercepts. So I know with this one, the y-intercept for, the y-intercept for the first one is a little bit lower than the y-intercept for the second graph. Then the third graph, the y-intercept increases at a faster rate. So what's happening to our graph in this, guys? All right, what's happening to our graph in this? Let's look at it. The y-intercepts are increasing as you change the what? A. Okay? And if you go back to what I was talking about earlier, the y-intercept will be that A. Okay? So the graph is exponential function is going close, 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 and whatever that y-intercept is, that A is, that's where it's going to hit the y-axis at. So if you have a larger A, it's going to increase faster, just like it was for a little bit for B. Okay? All right, so guys, go ahead and end this video. You guys are going to go to the second video so you can get a little practice on exponential functions. Okay? All right, good job today.